Hi there, hope you have a fantastic day today. This lesson, I will teach you how to work out the equations of a tangent to a curve. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, so we need to find the equations of a tangent to the curve at x is equal to a third for y is equal to 3x plus 2. So let me just quickly draw a diagram out first. So roughly we have ln of 3x plus 2. So just a rough sketch like that. So now what it does is we need to find the equations of the tangents roughly here, just to explain it to you, okay? So this is the equations of the tangent to the curve. So we need to find this equation. So step number one, what we need to do, we need to find the point first. That's number one. We need to find the point. So x is a third, and we need to find the y value, right? We need to find the point first. And second step is we need to find the gradient. And then third step is what we need to use this formula here, y minus y1 equal mx minus x1 to find the equations, okay? So now we have x equal to a third. So let's find the point first, step number one. So when x is equal to a third, so this means that y is equal to ln of 3x plus 2. So become ln of 3 times a third because x is a third, okay, at 2. And we know that these two cancel out. So ln1 is 0. And 0 plus 2 is 2. Otherwise, you can just put that on a calculator and you should get 2. So therefore, the point is a third and 2. So now we have the point, which is 2 here. And we need to find the gradient. Now to find the gradient at point, a third and 2. Now to find the gradient, so we differentiate this function first. So let me just write this down. Y is equal to ln of 3x, we add 2. Now remember, y is equal to ln of fx. To differentiate this, we differentiate the functions f of x, and then we over itself, that is over f of x. So y dash, it gives me f dash x over f of x. And we know that f of x is, in this case here, is 3x. So differentiate 3x, give me 3. So therefore, y dash is equal to 3 over the functions fx, that is 3x. And then we differentiate 2 is equal to 0. So we add 0. So we just ignore that. So that is the gradient. But then let me just simplify it first. So this 3 and 3 can both divide by 3. So the answer is 1 over x. So let me just write this down. So therefore, y dash is equal to 1 over x. So that is the gradient of the functions at any point. But then we will need to find the gradient at point a third and 2. Okay, so at a third and 2, that means x is equal to a third. So y dash must give me 1 over a third. So 1 divided by a third is equal to 3. Okay, so which is equal to 3. So therefore, the gradient of the tangent is 3. So that means this m is equal to 3. And we have the point, and this point here is a third and 2. Okay, so we have the point and we have the gradient now. So what we do, we use this formula here. This formula will help us to work out the equation of tangent. So let me just start from here. So we know that y minus y1 is mx minus x1. So we have the point now is this, and the gradient is this. So don't forget, so this is x1, y1. Now we just substitute that into a formula. So this means y minus y1, that is 2, m in this case is 3. And then x minus x1. x1 is a third. There you go. So now what I do, I expand the brackets and then I simplify, okay? So y minus 2 is equal to this time together, 3 times x is 3x. And 3 times negative 1 over 3 is negative 1. So negative 1. So now what I do, I just write in y equal mx plus c. Okay, we write in this form. Or you can make it into general form, that is ax plus by plus c equals 0, and still correct, okay? So let me just write in gradient intercept form. So y is equal to, I move this on that side, that becomes 3x. The negative 2, I move on that side, become positive. So minus 1 plus 2 is 1. So that is at 1. So therefore, the equations of the tangent to the curve is y is equal to 3x plus 1. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So we know the process, right? Step number 1, we need to find the point first. So we have a half already. So what we do, we substitute into this function here to give me y value, okay? So let me just clear this first. And then step number 2, that's number 1. Number 2, we find the gradient. Okay, to find the gradient, we differentiate the functions and we substitute the point into the gradient functions. That will give us the gradient at the point, okay? A half and y value. We're going to find it out, okay? And then we use y, number 3, y minus y1 is mx minus x1. So we just need to follow these 3 steps. So let me just find the point first. In this case, we already have x value. So when x is equal to a half, so y will give me ln of 2 times a half, okay? We add 6 times a half. So now a half times a half, that will give me 1. So then we know that ln 1 is 0, okay? So that becomes 0. We add, and what we do, 6 times a half is 3, so plus 3. So therefore, y is equal to 3. So now we have the y values. So the point is a half and 3. Or I can write here. So therefore, at point, okay, a half, 3. So now that we find the point already, we need to find the gradient. Okay, the gradient of the functions is we differentiate the functions first. So let me just write down y is equal to ln of 2x. And then we plus 6x, okay? That is the functions, but we want to find the gradient at point, a half, and 3. So we do that. So we differentiate this equal. So to differentiate this function here, so we use this rule. Y is equal to ln of f of x. So to differentiate this y dash, so we differentiate f of x. That give me f dash x. And then we over f of x, okay? That is the rule to differentiate, okay, log. So now what we do now is we know that this is f of x is 2x. So what I do, I differentiate 2x. So and differentiate 2x, it give me 2. So that means 2 over fx, and fx is 2x, okay? Keep that in mind. And we add, so differentiate 6x, it give me 6. So there you go. Now just simplify this. So that give me 1. So the gradient functions is this. Y dash equal 1 over x plus 6. But then we want to find the gradient at point, okay, at point a half and 3. So this means that x is a half. So we substitute x is equal to half into this. So that will give me y dash is equal to 1 over a half, and we add 6. And 1 divided by half is 2, and 2 plus 6 is 8. So the gradient is equal to 8. So let's say 8 here. So therefore, m is 8. So now we have m is equal to 8. So let's say this is 8 here. So now we just use this formula to work out the equations of the tangents, okay? So now let me just write this down. So we have the point and we have the gradient. So now we just use the formula. So the equation tangent is using this rule here. So equal m x minus x1. And we know that x1 is a half and y1 is 3. So now we just substitute that in there. So y minus y1 become y minus 3 equal m. And m is 8, the gradient, okay? And x minus x1. x1 is a half. So there you go. And now what I do, I just expand the bracket first. So y minus 3. So we have 8 times x. It give me 8x. So this is 8x. And 8 times a half, which is 4. So minus 4. So minus 4. So there you go. So now we can write either in this form, y equal mx plus c, or we can keep answer in general form, that is ax plus by plus c is equal to 0. And don't forget a, b, c, they are whole number and a is must be positive, okay, greater than 0. But in this case, we just put in this form easier, that's all. Doesn't matter what form you want to put in, okay? So now I just move this negative 3 on this side. So y is equal to 8x. And the negative 3 move on this side becomes positive 3. So this means that minus 4 plus 3. Give me minus 1. So there you go. So that is the answer. And I hope you got it correct. And thank you so much for watching. Bye.